All right, welcome back. I hope you enjoyed what does FX say. I'm pretty sure you didn't enjoy that. But one thing I will tell you is seniors who I had as freshmen that are walking these halls to this day will never forget what does FX say. It says why, right? So while you might not like it, it is effective and it does work. So now that we've talked about what function notation is, and we remember, we'll never forget what that fx and y are the same thing, let's talk about how we actually use function notation when we're working with our functions. And the first thing we're going to talk about is essentially simplifying, or another word that you'll see sometimes is to evaluate a function. All right. And when you are being asked to simplify or evaluate a function, you are going to be given an example that looks like this. It's going to have the letter of the function, so f, and then instead of the variable x, it's going to have a number or something other than that variable. In this case, it's 2. And guys, this is communicating to you. It's telling you that x equals 2. Remember, if we're starting with f of x, and we're saying f of 2, well, notice everything's the same except x was replaced by 2. And the only way we can replace things, substitute things, is if they're equal. But not only is it telling you something, it's asking you for something. It's asking you what is y. So it's telling you the domain, and it's asking you for the range. All right? So let's do that. And it's really pretty easy, guys. It's really just substituting and simplifying. So if we are working with f of 2, if f of x equals 2x, the question is, what's f of 2? Well, if I substitute 2 for x on the left-hand side, we know our golden rule with equations, whatever we do to one side, we have to do to the other. So I substitute over here. 2 times 2 is 4. And f of 2 equals 4. Please, guys, do not try and multiply f of 2 or divide by 2. F of 2 is one symbol, right? You can't break that up. Now, here's the question. That's function language. So this right here, this is function language. And I'm writing here, this is function language. How would we say this? How would this look in relation language? Well, again, what we know is we know x is 2 and f of x is y, and that's equal to 4. So essentially what we're saying here, f of 2 equals 4 is communicating the same exact relationship here as an ordered pair, 2, 4, an x coordinate and a y coordinate, right? This is relation language, x and y. All right. So function language, f of 2, which is x, equals 4, which is y. Relation language, 2, 4, x and y. They are saying the same exact thing. One is written in function language. One is written in what we'll call relation language. Now, here's the one thing, guys. If we start a problem in function language, we are going to be looking for an answer in our final answer to be written in function language. If you start in function language, you end in function language. It is totally okay to also include, if you also want to include the ordered pair, the relation language, that's fine, but don't just do the relation language in place of the function language. Also is fine, but not only. But not only. All right. So you can include also, but not only. Let's look at one more. Let's go to the last one here, and the other two I'll do in the notes, and you can check the notes on real-time board to see the answers there and try them on your own. But f of 2 here. Now again, notice there are 2 terms here with x, and that's okay. If we substitute for x once, we substitute for x as many times as it shows up here. So we'll end up with 2 times 2 to the third minus 2 plus 14. So as we work our way down, 2 to the third. Now this is big, guys. 2 times 2 to the third. Exponents come before multiplication. So I have to do 2 to the third first and get 8, and then I can multiply by 2 here. So this is 16 minus 2 plus 14. Right? And 16 minus 2 is 14. 14 plus 14 is 28. So please make sure, guys, notice The first thing we did, this came first, and then the multiplication. That's one of the biggest mistakes people make. Again, that's function language. That's what our answer should be written in. What is this in relation language here? As an ordered pair, this would be the same exact idea as the ordered pair of 2, 28. It's the content doesn't change, just the language with which we are expressing that content. All right, so there's several more examples up here. I'm not going to take the time in the video, guys, to do this, but this is good practice for you. So these examples here, we're asking you to evaluate, to simplify this function, to find what is y, what is the range, given 5 different domain values. So we're looking essentially for 5 different ordered pairs in relation language, or 5 different f of -1 equals blank, f of 0 equals blank. That's what we're looking for. Please try these on your own and go to the notes in the notes in real-time board to see how you did. What I want to spend the last bit of time we have in the video is talking about doing the same exact evaluating of a function, but doing it graphically rather than as an equation. It's actually easier graphically, but you guys are more comfortable with it as an equation. All right. And I think the key to understanding things graphically is to remember that function language and relation language are saying the same thing. So when we see a problem like this, when we see f of 6 equals blank, we don't know. What we're being told is we're being told what x is, and we're being asked for y. We're being told the domain and asked for the range. In other words, what we're being told here is an ordered pair where we know the x coordinate and we don't know the y coordinate. All right, so this actually doesn't require any simplification, doesn't require any arithmetic. It just requires us to be able to look at a coordinate plane and find an ordered pair with an x coordinate of 6 and a y coordinate that is actually on the graph. So when I come over here, right, my coordinate plane has a whole bunch of coordinates. Don't write this down, but that point right there has an x coordinate of 6. That one has an x coordinate of 6, x coordinate of 6, x coordinate of 6, right? All of these green points here, guys, have x coordinates. These are all ordered pairs with an x coordinate of 6. But the question is, which ordered pair has an x coordinate of 6 and is actually on the graph of f of x? Well, there's only one that does that, and that would be right here. Oops, I'm sorry, guys. I just realized all of my ordered pairs here are on 7, aren't they? Silly me. Hold on. Let's try this. Let's try this again. Let me just shift these all over. So now, I apologize, guys. All of those green points are on there, and we can see that the point is right about here. Now, notice that's not an exact value, but I can see I have 6, and we'll just call it 3.5. So when we look at this ordered pair, I would say that this ordered pair is 6, 3.5. Which means, guys, my function notation, what does f of 6 equal? F of 6 equals 3.5. And remember, this is the answer we're looking for, not the ordered pair. Function. We start in function notation, we end in function notation. Let's do another one here. If I'm looking for f of 4, essentially what I'm doing is I'm saying I know the x coordinate is 4. What's the y coordinate? What is a point on this parabola, which we'll talk more about parabolas in the second semester of algebra, but that's what this curvy thing is called here. All right, that has a coordinate of 4. Well, again, so let's take my points, and in all of these, everywhere I'm showing you right now has an x coordinate of 4, but only that point right there is an x coordinate of 4 and is actually on the graph. So we can see that this point right here is 4, 6. So f of 4 equals 6. All right, go ahead on your own and try f of 0 and f of 1. And then down here, this is called a piecewise graph. It's actually 3 different pieces put together as one graph. And go ahead and try these too. And please check your answer in real-time board, guys, because that's going to be pretty important that you're making sure you don't just practice them, but you practice them correctly. All right, well, that's the end of the target 3 notes. I know this is a lot of new information, guys. The actual work you're going to do really isn't very hard. There's not a lot of steps to it. There's not a lot of new pieces. It's more of just absorbing and engaging in this new language, kind of this new world of function notation. All right. Well, have a good one, guys. And as always, if you got questions, please, please, please reach out and ask us.